All right, here's section 5.2 book problems. This is 5.2 book problems for part 1. So just so that way you're aware. Okay, 22, 51, 56, and 83. Let's get going here. Okay, this one. It's a rational function. I need polynomial long division. I cannot use synthetic division, so I'm going to do some side work here. Polynomial long division, I need to do x cubed minus 4x squared minus 4x plus 20. Divided by x squared minus 5. I take these two terms, in case you forgot, and I do their ratio, and I see what I get. I get x. I'm going to put my x here because it lines up with these x's. You don't have to do that. That's not required. And then I take this x, and I multiply it by the whole quantity. So I get x cubed, and I get minus 5x. And please keep in mind that anything that you put underneath, you have to do the opposite sign. You have to subtract it, and you end up getting out negative 4x squared plus x plus 20, and you repeat. So let's repeat here. Because our job right now is to just integrate this, and I have to integrate it by doing some work here. So now I get negative 4x squared over x squared, which is equal to negative 4. So let's do minus 4. Let's take this part and multiply it times the whole thing. Okay, and I get 4 times, actually that's minus 4, oh whatever. 4 times x squared is going to be 4x squared, negative, and negative 4 times negative 5 is a negative 20, a positive 20 rather. But because we're subtracting down here, then this sign changes and that sign changes, and we end up getting just a single x. Perfect. So now let's rewrite our answer here. When I divide these two, I get x minus 4 plus x over x squared minus 5. So now let's rewrite our integral. So I get x minus 4 plus x over x squared minus 5 dx. Okay, so now let's integrate what we know so far. So I think we can find the integral of this one and of that one pretty easily. Antiderivative of x is x squared over 2 minus antiderivative of 4 is 4x. And then let's deal with this integral separately. So plus the integral of x over x squared minus 5 dx. This looks like a u sub because if I take the u on the denominator, its derivative is in the numerator mostly. I will put a plus c at the end because I did find an antiderivative here. Okay, now let's do a u sub. Let's draw a line, we'll partition. So if u equals x squared minus 5, du is equal to 2x dx. Now I don't have a 2x dx, I just have an x dx, so I need a 2, but then I need a half. So now I have a 2x dx. So now if I rewrite this, I still get equals x squared over 2. These terms are just waiting here. Minus 2x, and then I get plus 1/2 integral of 2x dx is du, so I have du over u. And the whole point of u sub is to make an integral look simpler, and that definitely did. So now I can actually continue, and I do need my plus c here still. Plus c, plus c. Oh man, this is so embarrassing. Oh gosh, plus c. Notice how smart this is. Okay. Alright, so now let's go and get the antiderivative again. So this is now going to be equal to x squared over 2 minus 2x plus 1/2 ln of the absolute value of u, but we can plug in u at the same time, x squared minus 5, and then don't forget communism, plus c. That's your answer, guys. This is for the first one. Polynomial long division was the key to this one. Next, 51. Okay, for 51, let's do a u sub, because I'm not really sure what the answer to 3x plus 1 is within the denominator. Some people are aware, and if you are aware, Maybe there's a reason why you're watching this video, but not currently. Okay, let's put a 3 on the top. But let's also take 3 on the outside. So a 3 on the outside. Okay. In fact, not only am I going to take a 3 on the outside, but I'm also going to take the 5, and I'm going to move that outside. I don't really want the 5 in there. Okay, now let's check and see what we have here. We have 3dx, that looks good. We have u is 3x plus 1, so we can rewrite everything. Sort of. So I get 5/3. So I'm going to do 5/3. Integral. Do not put 0 and 4 yet. Wait for that. It looks like du over u. Du is 3. dx, 3x plus 1 is u. Now, the reason I can't do my limits of integration here for 0 and 4 on the blue integral is because these were x equals 0 and x equals 4. Because our integral is with an x. But when your integral is with a u, then you need u's here. So how do we change them? Right here. You need to do u of 0, and you need to do u of 4. The reason we have 0 is because that was our lower limit of integration. And actually, I'm going to switch that order. Let's see, well, let me switch. Nope. Okay, I'll erase it. I'm going to switch this order just so you can see top and bottom. I don't know if you necessarily need that. I'm going to do it anyway. Okay, so u of 0 is equal to 1, because I did 3 times 0 plus 1, and u of 4 looks like it's going to be 13. So these values in yellow go here. So let's change that now. U is equal to, on the bottom, 1. The beautiful part about doing this is that you don't have to ever go back to the original values again. This 13 was this 4, so let's put it here. So we'll put 13 here. Okay, now we're ready to find the rest of the antiderivative, so we'll continue. Actually, I'm going to put a little note here because it's super important. Change. Oh, nope, that's not the right spot. Let's try that again, Mr. Lakin. Change your limits of integration. Integration with u sub. U sub. Let's put an exclamation point. Okay, to continue on, antiderivative 5 of 1 over u is going to be 5/3 ln absolute value of u evaluated from u equals 1 to u equals 13. Notice we don't need an absolute value because our limits of integration are positive, so we got 5/13 ln of 13 minus 5/3 ln of 1, and ln of 1 is 0, so because ln of 1 is 0, that's out, and we get our answer here. That's the exact area between 0 and 4 and the function of the x-axis. Okay, let's go on to the next one. 56, kind of the same problem. Let's do some polynomial long division, because I can't do a u sub here, because if I do a u sub, I mean, it's not, oh wait, that doesn't look right. It can't be x minus 1 over x minus 1. It's x minus 1 over x plus 1, Mr. Lakin. Okay, so let's do plus 1. I can't cross them off. Same degree, same as I do long division, or synthetic. You could do synthetic division here. It looks like it's going to be a 1. Goes here because of x over x. That's going to, when you multiply it out, you get x and a plus 1. But subtract them because you're subtracting when you put them on the bottom. You get minus 2. So now what we can write this as is the integral from 0 to 1. Limits stay because we still have x's. Okay, now we get 1 minus 2 over x plus 1. And now we can integrate term by term. So the antiderivative of this one is going to be x. And the antiderivative here will be minus 2 ln absolute value of x plus 1. If you needed to, you could have written that separately on the side to see if that's really true. The antiderivative of 2 over x plus 1 is equal to 2 times the integral of 1 over x plus 1, which is equal to, and again, a lot of students may not need this, but if you did need this, please use it. Not a lot of students. There may be some students that didn't need this. I'm just trying to show all the steps that I possibly can. The reason this is advantageous because this is something to the first power, and we did have in our notes that anything to the negative first power, the integral of u to the negative 1 du is ln absolute value of u. So that negative 1 is the giveaway there, which is why I did an ln. Okay, let's keep going here. Now I'm going to evaluate this from 0 to 1. And then we do top minus bottom. So let's do 1 minus 2 ln of 2. Remember I dropped the absolute value because I don't really need it. And then we're going to do, because absolute value of 2 is 2, then we're going to do minus, let's plug in 0. 0 minus 2, put parentheses, 0 minus 2 ln of 1. Oh, look at that. Ln of 1 again is 0. So all of this is 0, because it's 0 minus 0. So your final answer, 1 minus 2 ln 2. Another possible answer is equal to 1 plus ln of 2 to the negative 2. Another possible answer could be 1 plus ln of 1/4. Any of those answers would be fine. The reason I wrote them down is please make sure you are paying attention to your properties, because that would be a multiple choice. Any of those could have been a multiple choice option. Okay, let's keep moving on. See what I did there? I made a car to show that we are moving on. Okay, we're getting a sidetracked here. Let's keep going. Last one, 83. Okay, this one. Let's go ahead and do, we're solving for x here. Let's go ahead and just find out what this antiderivative is. We get 3 times ln absolute value of t, evaluate from 1 to x. Now it looks like we have an equal sign here. Let's do the other side. Equals natural log absolute value of t, because that's what the antiderivative of 1 over t is. Evaluate from t equals x, t equals 1/4 to t equals x. Okay, let's keep going here and see what we get. Now we're going to get in blue, we get 3 times ln of x minus 3 times ln of 1. Wow, they really like that ln of 1. I should note here that this is an absolute value of x because we don't know what x is. We have an equals, and we have natural log absolute value of x minus natural log of 1/4. Okay, next let's go and see if we can solve this equation then. Natural log of 1, this is 0. So now we have 3 ln x on the left equals ln absolute value of x. I'm going to change this to plus natural log of 4. I moved the negative 1 up and did a reciprocal of 1/4 to make 4. Okay, I'm going to also subtract an ln x on the other side. So subtract ln of absolute value of x on both sides of the equation. And now I end up getting 2 ln absolute value of x equals ln of 4. If we divide both sides by 2, we get ln absolute value of x is equal to 1/2 ln of 4. But if I put a 1/2 here, that's the same thing as moving it up here, which is ln of 2. The reason it's ln of 2 is the square root of 4, which looks like the absolute value of x is going to be equal to 2. Thanks for watching, guys.